Hi everyone, very good evening. A very warm welcome to today's session. We will be talking about horizontal pod autoscaling in Kubernetes. Imagine you are working in an organization where you have deployed an application, a web application, and you have made an observation in the peak time, let us say in the morning time, there is a lot of traffic, lot of users accessing the web application. And as the number of users are increasing, the number of user requests coming to the applications increase, the performance of the application slows down. So you may have to increase the capacity, the resources of the application, or the number of servers have to be increased where your application is running so that you can manage that large number of user traffic. You also observed in the evening time, during the less peak hours, the number of users accessing the web application have reduced. So in those times, you do not need those extra virtual machines or extra resources that you have allocated in the morning time. Right? In this case, you are manually scaling up your application when required and manually scaling down your application when you do not require it, when there are less number of traffic. Isn't it? However, doing this job 24/7, monitoring the traffic on your application and scaling up and scaling down the application resources as well as the servers manually is a difficult job to do. Hence, we make use of an automation tool, Kubernetes over there. Of course, Kubernetes has many other features that we have been learning and we will be learning in future. So far, we have already seen what is a pod in Kubernetes, what is a service, and deployments in Kubernetes. We have also seen that deployment is an object which creates multiple pods and helps you to manually scale up the pod or scale down the pod on the Kubernetes cluster. Considering the example of lot of traffic coming to your web application in an organization, we can use Kubernetes to deploy the pods and then scale them up and scale down. However, deployment also gives us a manual command to scale up and scale down the pod. Service is an object which redirects the traffic to your pod within the cluster or outside the cluster via the service of type node port or load balancer. We have seen that. Now, the use case today we want to talk about is if there is a pod. Let us say I have deployed, let's call this a deployment, where there is a single pod running. We call the pod of an image, let us say Nginx. Every pod that you create gets a default resources that it can use any number of resources on the node where it is scheduled. However, you can restrict that by allocating resources section in your pod specification. Resources that are allocated to the pod are two. One is the CPU core and the memory. There are two resources that we allocate to a pod, CPU core and memory. CPU core is measured in core units. One CPU core is equal to 1000 milli-CPU. And memory is measured in megabytes. So there are two resources that we allocate, CPU and memory. CPU is measured in core. One CPU core is equal to 1000 milli-CPU core. Memory is measured in megabytes. Once these resources are allocated, you can allocate maximum resources that are given to a pod. The max limit can be allocated and the given resources to the pod. Isn't it? Now, once the resources are allocated to the pod, we also have an object which is a service object. The service object acts like a proxy. Forwarding the user request to your pod. So we have a service object, let's say, which is forwarding the user traffic to the pod. So let us say I've got very few users. So my single pod will be able to manage all the resources. However, as the number of users increase, as the number of user requests are increasing, the requests which are going to the pod also increase. The number of requests going to the pod are also increasing, and the pod CPU resources will get utilized. As the pod's CPU resources are getting utilized, right, it will not be able to handle more number of resources more number of requests that are coming to it. Hence, we need to create a new pod. So we will scale up this pod. Since it is a deployment, we can scale up. So once I scale up the pod, service object will now be responsible to forward the request to the new pod. It will load balance the user request to the new pod. However, as the resources are consumed for this pod, we need to create a new pod. But creating this manually is not what we want to do. We want the scaling up of the pods to happen automatically. And that is where our today's topic will come into picture, which is horizontal pod autoscale. So if I remove this, so we can deploy, in addition to a deployment object, a pod and a service, we will deploy a new object called as horizontal pod autoscaler. A horizontal pod autoscaler requires few important objects to monitor. A horizontal pod autoscaler is also called as HPA, horizontal pod autoscaler. Now, a horizontal pod autoscaler requires a reference, a scale reference point where it can scale up the pods or scale down the pod. So a horizontal pod autoscaler, we have to feed the target to scale. So we will give the name of the deployment, which has to be scaled up or scaled down. In our case, this deployment name has to be given that we will scale up or scale down. And you will always give minimal number of pods to be maintained. Let's say I'm giving 1, and max number of pods to be scaled. Right? Minimum number of pods to be maintained, maximum number of pods that this autoscaler can scale up. Okay, so let's say I'm giving 100. So this autoscaler is having the capacity to create 100 pods of the same image, of the same pod specification it will create. Great. In addition to this, when should HPA, the horizontal pod autoscaler, should create the pods? When should it scale up? What is the trigger point for it to scale? So then we give something called as percentage of CPU utilization. CPU utilization on the pod. So you give a percentage over here. So let's say I'm giving 80%. So if 80% of the pod CPU has been utilized, then scale up the pod, right? So we'll give a percentage. So generally we give 75 to 80%. Okay. If the 80% of CPU is utilized on the deployment, then we should scale up the pod, right? So horizontal pod autoscaler, just a quick summary. Horizontal pod autoscaler monitors a deployment or a target reference that it can scale up or scale down. As part of this target reference, it is monitoring the percentage CPU utilization of the pod. If it has reached 80%, it will scale up the pods. It can scale up till 100. If the pod CPU is not being utilized, the HPA will scale down the pod. It will automatically scale down the pod. So let's go ahead and do the demonstration of this. As part of the demonstration, I will be creating first a deployment where we will create one replica pod. One replica is nothing but one pod of Nginx. We'll also create a service that will forward the user request to the pod. Right now, I'm not creating a load balancer or a node pod service. I'll create a ClusterIP service so that I can send the request to the pod within the cluster. Then I shall be creating a horizontal pod autoscaler, which will monitor the deployment and scale up and scale down the pod. In the last, we will create a load on our deployment. So we will create a load generator pod. We will use a load generator pod that will generate a lot of load, lot of user requests onto our pod. Okay, so we'll create a load generator pod that will send multiple thousands of requests to the service object. Service object will forward it to the pod. Pod CPU will be utilized. As a pod CPU is utilized, horizontal pod autoscaler will scale up the pod. Okay, so we are going to see this automated process of scaling up and scaling down of the pod. So let's go ahead and see this. I already have my Google Kubernetes Engine up and running. I'll quickly connect to the cluster. Now, for HPA to work, we need a metric server to be installed on the cluster. In the cloud clusters of Kubernetes, metric server comes pre-installed. If you have your own local Kubernetes cluster, then you will have to install the metric server on your master node or on your Kubernetes master. Only then HPA will be able to gather the resources of the pod. What are the two resources? CPU and memory. Metric server works with a command called as a top command. I will show that command to you in a minute. Using that command, HPA will get the number of pods, their CPU, and their memory information. So we'll wait for it to start. Okay, so I am connected to my cluster now. So as part of my cluster, I've got 3 nodes. I do not have any resources yet, only a Kubernetes service running. Okay, so the first thing is we are going to deploy a single pod. I'm also going to open a terminal where I'm going to watch the number of pods that I have created. So I'll run a query watch kubectl get pod. So it will keep showing me the number of pods that are running. Right now, I don't have any pods in my cluster. I'll also open a terminal where I'm going to run a query for metric server that will show me kubectl top pods is the query that will show me the number of resources on my pod, the CPU and memory on my pods. So right now I don't have any pods, so the CPU and memory will be 0. Right now there are no resources. Okay. If you want to see, you can also see the top command to see the resources of the nodes in the cluster. So here it is showing you that the CPU percentage and memory percentage of each of the worker nodes in the cluster. So this is computed by the metric server, which comes pre-installed with the cloud clusters. We'll keep it as top pod. Okay. Now we'll write the deployment YAML file. So I'll say HPA deployment.yml. As part of this deployment, we'll start with API version. In Kubernetes, API version is apps/v1 for deployment. We'll give the kind of object that we want to create deployment. We'll give the metadata, the name of the deployment. Let's say Nginx. That's the name of the deployment. We need to remember this name. The horizontal pod autoscaler is going to use this deployment name. We will then give a specification, the number of replicas I want to create. Right now with the deployment, I want to create a single replica. We will give the selector where Kubernetes is going to query, are there any pods with the match labels? So we'll give the matching labels. So I'm going to set the label on my pods as app as Nginx. So right now I don't have any such pods with matching label app as Nginx. I'll create the template now, the pod template. The pod template includes the labels on the pod, which should be as we have given above. App as engine. After which we will give specification section. Now this should be part of metadata. In the spec section, we will give the number of containers. We'll give the name of the container and the image on the container as engine. Now, the important part over here that we are going to give is the number of resources on the container. By default, a container can utilize the complete resources of the node on which it has been scheduled. But we will restrict its resources. We'll give the number of limited CPU to it. Limit. CPU is, let's say, 1 millisecond or 10 milli-CPU we will. Generally, you can give 500 milli-CPU, that is 0.5 CPU core. However, I have to show you the increase of the pods or scale down of the pods immediately during the session. Hence, I'm keeping the CPU, limited amount of CPU, which is 10 milli-CPU only. So this is the deployment YAML file. Let's go over it one more time. The kind of object that we are creating is a deployment, which is having the name as nginx. A specification says that it will create a replica. One single replica we are going to create. What will be there on the pod? What's the pod specification for the replica? Here we go to the template. Template tells that the pod will have the label app as nginx, and the pod will have a container with the image nginx and the given resources of 10 millisecond. After this, we are also querying the cluster. Are there any pods with these matching labels? We don't have it. So create the pod using the following template. So this is your deployment object. We shall now go ahead and create the deployment. To create the deployment, Kubernetes command kubectl create -f, the deployment YAML. So you can see here the number of pods have been created. One pod has been created. In the pod, there is one container. Container is in creation status. Computing the CPU and memory of the pod will take some time, at least 1 minute, and only then you will be able to see the top commands. Okay, the pod is now running. Now, in order to access the pod, in order to access the application on the pod, we also need to create a service object. Service is a very important object in Kubernetes that allows us to access our pod within the cluster or outside the cluster from your browser. So I am going to create a service of type ClusterIP so that I can access the pod within the cluster. So we will start over here, service HPA. So API version for services like a pod, it is the core object of Kubernetes, V1. The kind of object that we are creating is service. Let us give a name to the service, metadata. Then we will give specification of the service. In the spec section, we'll give the type of service. So the default type is ClusterIP. So even if you do not mention ClusterIP, by default, it creates a service of type ClusterIP. Then we will give the selector, select the pods. So service needs to send the traffic to which pod? What are the endpoints of the service? So select those pods with the label app as engine. So selector here indicates select which pod to which the traffic has to be sent. Or you can simply call it as the endpoint of the service object. So select the pod with the label app as engine. Okay. Then we will give the port mapping. Ports. We will give a service port 80 and the target port. is also 80 for Nginx. Let us save this and create the service. Let us go over the service YAML one more time. The YAML is going to create an object of type service. The service will be created of type ClusterIP. That means any pod within the cluster can send the traffic, can send a request to another pod within the cluster. So we are going to create a load generator pod. Using this cluster IP and the port number 80, we can send the request to our Nginx pod. So this particular service will be able to forward the user request to the pod which is having the label app as Nginx, which is nothing but the deployment. And the ports the target port of is 80 because we have chosen image as Nginx. The service port is 80. So this particular YAML, when executed, should give you an internal IP address. So it's the same command, kubectl create -f, the YAML file, create the object which is present inside this YAML file. So our service has also been created. You can see all the objects that have been created by you via the command kubectl get all. So here we can see one deployment was created. Deployment gives us a replica set. A replica set is responsible to create a replica. Then a service Nginx has been created, which gives us an internal IP address and the port number 80, which will forward the request to this. Okay. Now I need a monitoring tool. Like HPA is like a watchman, which monitors your replicas, which monitors your deployment. That's the name of the deployment. It can scale up the desired count of replicas or scale it. Okay, so let's go ahead and use it. Let me create HPA, horizontal pod autoscaler YAML. So this particular object has an API version of autoscaling. The kind of object that we want to create is horizontal pod autoscaler. We will give the metadata. We'll give the name of the HPA. We'll give the specification of the HPA. As I said in the diagram, HPA needs the scale target reference, the minimal replicas, maximum replicas, and the target percentage CPU utilization. Okay, so we'll give the specifications of the HPA. Scale target reference. Target T is uppercase, it's all in camel case. We'll give the API version of the object that we want to scale. It is nothing but apps/v1. The kind of object that we want to scale, deployment, and what is the name of that object. Nginx is the name of our deployment. Then the number of replicas that HPA can create, minimal replicas. Let's give as 1. And max replicas. For now, I will give 10. Okay, you can set any count here. The last parameter, which is very important, target CPU utilization percentage, which is 5. Okay, I'm going to set it to 5 over here. So if 5% of CPU has been utilized, then the new replica will be created. Now you may set it to 70 or 80%, but we are setting it is very, very low today. The reason being I have to quickly show you the auto scaling and scaling down within the session. Otherwise, you can set a very high number over here. All right. What is target CPU utilization? Let us discuss that via the Kubernetes documentation for a minute. So if you go to kubernetes.io, its official website, and if I take you to the horizontal pod autoscaler, and if you look at its CPU utilization, okay. For per pod resource metrics, CPU will be set. The controller fetches the metrics from the resource metrics server, as I said, for each pod that is targeted by the horizontal pod autoscaler. The horizontal pod autoscaler targets every pod. Each pod will get the metrics. We have seen here, each pod gets the metrics, CPU and memory. Then if the target utilization value is set, we have set the target utilization value as 5%. Okay. By default, we have given the CPU core as 10 milli CPU. So 5% of 10 milli CPU core is what we have to monitor. If the target utilization value is set, the controller calculates the utilization value as a percentage of the equivalent resource request of the containers on each pod. If the target raw value is set, the raw metric values are used directly. Okay. We'll take the mean utilization or the raw value and calculate the percentage of the utilization and increase the pod or reduce the pod. All right. So this is your horizontal pod autoscaler YAML file. Let us save this. And let's create the horizontal pod autoscaler. Let us see, there is a mistake in the API version. Okay, let us just quickly pick it up from here. You can always find the YAML files over the Kubernetes. We have already done the deployment. We just need to create the autoscaler. You can also create the autoscaler via a single line command as shown over here. Let me just pick it up from here. No problem. Let me correct the spelling. So I will just quickly change the spellings here. All right. Let us see. Okay, the HPA has been created successfully. You can say kubectl get all to see your HP. Now, when you see here, the horizontal pod autoscaler has been created. It's referring to the target deployment in Nginx. Right now, we don't know the percentage utilization of the resources on the pods. Minimal 1 pod it is going to maintain, maximum 10 pods it is going to maintain. So your infrastructure of the auto scaling has been set up. Now the real action has to be done. We need to create a new pod, or generally you can use a load testing tool like Load Runner or Apache Benchmark or JMeter. To those automation tools, you may create multiple virtual users that are continuously sending a request to this IP address. But right now we are not having a load testing tool. So we will create a load generator pod, a pod that is going to send continuous request to this IP address and the port number 80. So let me show you the, let me take a new terminal and let me show you the command. So I am going to write a command here. kubectl run, kubectl run. Okay. In an interactive mode, interactive terminal mode, create a pod with the name load generator. That's a new pod we are going to create with the name load generator. I'm giving the option RM so that the pod, when I stop the pod, pod should get deleted. The pod will be created with an image of BusyBox. It is an operating system image. Then I am also giving an option restart never. So if the container in the pod fails, I do not want to restart it. By default, the restart policy is always. If the container inside a pod fails, it will always restart. I've set the restart policy as never. Then I want to attach to the bin and sh, the bin terminal. Bin sh terminal of BusyBox. BusyBox come with a terminal of type shell sh. Okay, and then we will execute a command. What is a command? A loop command. What is a loop command? The command is while we wait, that is sleep, for 0.01 seconds, let us give. Do. So we are writing a loop over here. Loop is something which repeats a task again and again. So wait for 0.1 seconds and then do a task. What is a task? wget. That means send a request to our service, the name of the service or service IP, port number 80. Okay. Just keep sending the request to port number 80, or that is a service. Service will forward the request to the deployed pod, this particular pod. As the request comes to the pod, CPU will increase. As the CPU increases, HPA monitors the CPU. As the 5% of the CPU is utilized, HPA will create a new pod. We should see that. Scale up the pod. Okay. So please have a look at this command one more time. Look at the command. kubectl run the image BusyBox, create a container or pod, create a pod with the name load generator, attach to the terminal of the pod, right? Run the pod, run the image BusyBox, create a pod load generator with the name load generator, attach to its terminal, right? Bin and sh, attach to its terminal and execute a loop command. What is the loop? While loop we are writing, that is continuously send a request to the service IP address port 8. Also, we are giving here RM option. That means if I stop the pod, pod should get deleted. If the pod has been created and the container is failed, do not restart it. Just a load generator pod. Let me run it. It should immediately, I forgot to give a quotation at time. Let me rerun. kubectl minus I minus tty load generator rm image is equal to, equals is missing, image is equal to BusyBox, restart is equal to never, bin and sh command, sleep, do wget. Let us recheck. Okay, got the command again. I'll just replace it with the service IP address. Port 80. So kubectl run and create the load generated pod with the image BusyBox. Remove it if it is stopped. Restart never, bin and sh, and execute the command. Okay, there was a space missing over here. Okay. Now please see, it is continuously sending the request to the Nginx pod. There will be thousands of requests which are coming to the pod. As the number of requests are going to the pods, you will see slowly the CPU has increased and HPA will create new pods for you. So we'll wait for a couple of seconds for it to scale up. You can see here, the requests are still going. Now, can you see? The Nginx pod CPU is 6 milli CPU. As the more number of requests goes, so this is like a load generator. Continuous requests coming from various users to your service forwarding the request to the pod. You can see the creation of the new pods, friends. Auto scaling of the pods. You can see your HPA. You can query your HPA, kubectl get the HPA. You can see the target reference and the maximum number of replicas that it has created at 10 already created. So you can see 10 pods are up and running. Requests are still coming and you can see the utilization of the CPU. Now, if I stop the load, if I don't send the load, if I stop the load, immediately, not immediately, it will take some time. That the CPU of the pods will start reducing and HPA will start deleting the pods for you. Okay, so scaling down will also be taken care by HPA and scaling up also. All right. So this was your horizontal pod autoscaler in Kubernetes, where we were able to target a deployment object and where we were able to increase the pods or reduce the pods by using horizontal pod autoscaler and its minimal pods and max pods criteria that we have given, we were able to increase. All right. So this was about the horizontal pod autoscaler for you. Let me stop the pod. As I stop the pod of load generation, immediately the pod gets terminated because we have given the RM option. And slowly the CPU will reduce to 0 and HP will start reducing. So that will take few minutes to reduce it. It doesn't kill the pods immediately. All right, that's all for the horizontal pod autoscaler in Kubernetes. You may read about it on the Kubernetes documentation also. A horizontal pod autoscaler which automatically will upload or update or scale up your workloads. Now, horizontal pod autoscaler can also be applied on stateful sets to automatically scale up or scale down your pods. I hope you thoroughly enjoyed today's session and you have clearly understood the concept of HPA. Thank you so much, everyone. Please do not forget to delete your cluster once you have completed the testing or you've completed the practice of HPA. All right. Thank you so much, everyone. Bye-bye.